Students, myself Dattatreya Jadhav, I am from sgm College, Karad. Today we are going to discuss new chapter from Mathematics paper 2nd. The name of the chapter is Integration. So my first question is, derivative of x cube is what? Dx of x cube is equal to what? Derivative of x cube is, it's 3x square. Yes, derivative of x cube is 3x square. So my second question is, whose derivative is 3x square? Whose derivative is 3x square? The answer must be derivative of x cube is 3x square. So that x cube is called as antiderivative. Or primitive. Or it is also called as integral of x square with respect to x, that is x cube. So symbolically we can write here its symbol for integration, integral of which function? 3x square. The integration done with respect to x, so write dx. Integration of 3x square dx is equal to what? X cube. Okay. Now my second question is, tell me the derivative of ddx of x cube plus 1. Okay. Here inside the derivative there is addition, so we can separate the derivative ddx symbol. Derivative of x cube, derivative of x cube is 3x square. Derivative of x cube is 3x square plus ddx of 1. Here 1 is constant. Derivative of constant is 0. Don't write there. So now again my question is, whose derivative is 3x square? The answer must be, yes, derivative of x cube plus 1 is 3x square. So x cube plus 1 is called as antiderivative of 3x square, or it is also called as integral of 3x square with respect to x is what? Now x cube plus 1. Okay. Again my question is, tell me the derivative of ddx of, yes, derivative of x cube minus 1. So your derivative of x cube minus 1 is, again inside the derivative there is subtraction. We can separate ddx symbol. Derivative of x cube is 3x square minus derivative of 1 is, it's 1. Derivative of 1 is 0. Don't write. So again, whose derivative is 3x square? Answer is x cube minus 1. So I can write integration of 3x square with respect to x is what? X cube minus 1. So simple definition is what? Integration is, it is inverse process of derivative. Okay. Now here in first case we get integration of 3x square dx is x cube. In second case we get integration of 3x square dx is equal to x cube plus 1. In third case we get integration of 3x square dx is equal to x cube minus 1. Okay. In all the cases on RHS there is a common term x cube. So I can write integration of x cube 3x square dx, integration of 3x square dx is equal to x cube. But we don't know exactly which constant is 0 here. Either it's +1 or -1 or any constant. So we introduce here that constant by C, and that C is called as constant of integration. So such type of integrations are called as indefinite integrations. Okay. Now symbolically we write the definition of integration as, okay, if ddx of f of x is equal to g of x, then yes, my question is, whose derivative is g of x? The derivative of f of x is g of x. Answer is f of x. Then f of x is called as antiderivative, or it is also called as primitive, or it is also called as integral of g of x. Integral of g of x with respect to x is nothing but f of x. Okay, its symbol for integration. Here the function is called as integrand, and dx is integration is done with respect to x. Okay, plus constant of integration c. You can write or not write. Here it is the first equation and it is the second equation. Now I can use equation second in equation first. Equation second means what? Here is the value of f of x. F of x value is what? Integration of g of x. I can use equation second in equation number first. So it becomes ddx of value of f of x is what? Integration of g of x. So integration of g of x dx is equal to, yes, here integration and derivative are cancelled with each other, and answer is g of x. Just put the value of equation second in equation first. Okay, and when we use equation first in equation second, means we use value of g of x. Value of g of x is ddx of f of x in equation number second. So integration of, yes, value of g of x is what? ddx of f of x. So integration of ddx of f of x, okay, with respect to x is equal to, here answer is f of x. Means, look at here, if there are symbols, derivative and integrations, then they are cancelled with each other and we get g of x. Here is also integration and derivative symbol are cancelled with each other and we get only f of x. Okay, so again one point to remember is derivative and integrations are inverse processes of each other. Okay, and also integration and derivative are inverse processes of each other. Now from the formulas of derivative we find some formulas of integration. Okay, so start with the first formula of derivative. Yes, so we know that ddx of x raised to n plus 1 divided by n plus 1. Okay, tell me the derivative of x raised to n plus 1 divided by n plus 1, which is equal to, here n is constant, n plus 1 is constant. If inside the derivative there is constant, take outside the ddx symbol. So it becomes 1 upon n plus 1. It is constant, so take outside. And what's remaining here? Derivative of x raised to n plus 1. We know that derivative of x raised to n is n into x raised to n minus 1. So derivative of x raised to n plus 1 is n plus 1 into x raised to n plus 1 minus 1. Here, what get cancelled? N plus 1 get cancelled. Plus 1 minus 1, 0. So what's remaining? It's x raised to n. So ddx of x raised to n plus 1 divided by n is equal to x raised to n. This implies from our definition, which definition? d dx of f of x is equal to g of x. Then we say that integration of g of x dx is equal to f of x. So tell me, d dx of x raised to n plus 1 divided by n plus 1 is equal to x raised to n. So this implies integration of x raised to n with respect to x is equal to, yes, answer is x raised to n plus 1 divided by n plus 1 plus constant of integration is c, because the formula is for indefinite integration. Okay, there is one point to remember, where n plus 1 is not equal to 0, that is n is not equal to minus 1. For example, here is the first formula for integration of x raised to n dx is equal to x raised to n plus 1 divided by n plus 1 plus constant of integration c. Remember, here base is variable and power is constant. So first we find integration of x raised to 5 dx. Okay, integration of x raised to 5 dx. Here x is variable and 5 is constant. So integration of x raised to 5, it looks like integration of x raised to n. Integration of x raised to n is x raised to n plus 1 divided by n plus 1. So add power by 1, here power is 5, answer is x raised to 5 plus 1, that is 6 divided by 6 plus constant of integration. It's very simple. Integration of x raised to 5 dx is equal to x raised to 6 divided by 6 plus constant of integration c. Take another example. Integration of x raised to 3 by 2 dx is equal to, look at here, base is x and power is 3 by 2 constant. So add power by 1. Okay, x raised to 3 by 2 plus 1 divided by same power 3 by 2 plus 1 plus constant of integration c, which is equal to, tell me, 3 by 2 plus 1, it's 5 by 2, x raised to 5 divided by 2 whole divided by 3 by 2 plus 1, again it's 5 by 2 plus constant of integration c. Okay, now simplify. Yes, it's 2 divided by 5 into x raised to 5 by 2 plus constant of integration c. Here is our first formula for integration. Integration of x raised to n dx is equal to x raised to n plus 1 divided by n plus 1 plus constant of integration c. Now for second formula, we know that d dx, tell me the derivative of log x. Derivative of log x is what? It's 1 upon x. So it implies that, yes, use the definition of integration. If d dx of f of x is equal to g of x, this implies integration of g of x dx is equal to f of x. So integration of 1 upon x dx is equal to log x plus constant of integration c. Now here we don't know what x is positive or negative, but we can define only logarithms of positive terms. So put bracket there. So put modulus sign there. So integration of 1 upon x dx is equal to log of mod x plus c. Okay. Next, third formula is there, d dx of, we know that derivative of e raised to x. What is the derivative of e raised to x? Is e raised to x. So simply integration of e raised to x dx is also e raised to x plus constant of integration c. Okay, by using the definition of integration. Fourth, d dx of a A. But we are interested in finding the formulas for integration of standard function, that is a raised to x. Here log a is constant. Okay. So take log a on LHS. Therefore, it's 1 upon log a into d dx of which function? It's a raised to x is equal to a raised to x. Now, if there is a constant inside the derivative, we take it outside the derivative. Now, here what happened? The constant is outside the derivative. I can write this inside the derivative, multiplying by taking 1 upon log a inside the derivative. So we get, yes, d dx of a raised to x divided by log a is equal to a raised to x. This implies that integration of which function? A raised to x with respect to x is equal to a raised to x divided by log a plus constant of integration c. Okay. For example, remember here to use formulas of derivative or integration. Here a is a constant term while power is a variable. For example, integration of 3 raised to x dx is equal to, look at here, integration of a raised to x dx is what? A raised to x divided by log a, and here base is what? A, constant, and power is what? Variable, x. So integration of 3 raised to x dx is equal to 3 raised to x divided by log 3 plus constant of integration c. Okay. Now moving to our next formulas. We know that derivative of root x. Derivative of root x is what? 1 upon 2 root x. d dx of root x is equal to 1 upon 2 root x. Remember, we are not interested in constants. Okay, take 2 on LHS or multiply both sides by 2. 2 get cancelled. It becomes 2 into d dx of, yes, root x is equal to 1 upon root x. Okay, derivative of root x is 1 upon 2 root x. Take 2 on LHS. Okay, 2 is outside the derivative. Take inside the derivative. So d dx of 2 root x is equal to 1 upon root x. It implies that, okay, derivative of 2 root x is equal to 1 upon root x, and we know that integration is inverse process of derivative. So integration of 1 upon root x with respect to x is equal to 2 root x plus constant of integration c. It's our next formula for integration. Integration of 1 upon root x is equal to 2 root x plus c. Next formula is d dx of, yes, we know that derivative of 1 upon x. What is the derivative of 1 upon x? It's minus 1 upon x square. Minus 1 upon x square. Okay, derivative of 1 upon x is minus 1 upon x square. Now, just look at here, minus sign is there. We are not interested in that minus sign or constants. Okay, take minus sign on LHS. Therefore, or multiply both sides by minus 1, we get minus d dx of, yes, 1 upon x is equal to, minus minus becomes here plus 1 upon x square. Here minus sign outside the derivative, take inside the derivative. d dx of minus 1 upon x is equal to 1 upon x square. This implies that integration of which function? 1 upon x square is what? Integration of 1 upon x square is minus 1 upon x plus constant of integration is c. Here is the formula for integration of 1 upon x square dx is equal to minus 1 upon x plus c. Now, we know the formulas for derivatives of trigonometric function. Okay, derivatives of trigonometric functions such as sin x, cos x, tan x. Okay. First, we see ddx. Yes, ddx of tell me derivative of sin x. Derivative of sin x is what? It's cos x. By definition of integration, if derivative of sin x is cos x, whose derivative is cos x? Answer is sin x. So integration of cos x, okay, with respect to x is equal to sin x plus constant of integration c. Here is the next formula for integration. Integration of cos x dx is equal to sin x plus c. Next, ddx. We know that derivative of cos x. Derivative of cos x is what? Derivative of cos x is, yes, anyone? Minus sin x. Okay. Now here minus comes on RHS. We are not interested in that symbols. So multiplying both sides by minus 1. So minus ddx of, yes, cos x is equal to minus minus becomes plus. It's sin x. Take minus sign inside the derivative since it is a constant. So ddx of minus cos x is equal to sin x. So it implies that integration of which function? Sin x is equal to integration of sin x is what? Minus cos x. Minus cos x plus c. It's our next formula for integration of sin x dx is equal to minus cos x plus c. Also we know that derivative of tan x ddx of tan x, derivative of tan x is equal to what? Derivative of tan x is sec square x. So simply, yes, by using definition of integration of sec square x is what? Integration of sec square x dx is equal to, yes, it's tan x plus c. Tan x plus c. So it's our new formula. Integration of sec square x dx is equal to tan x plus c. Next, we know that derivative of also cot x, cosec x and sec x. Okay. So next formula is derivative of ddx of, yes, cot x. Derivative of cot x is what? Derivative of cot x is minus cosec square x. So multiplying both sides by what? Minus sign. So minus ddx of cot x is equal to minus minus becomes plus. It's cosec square x. Take minus sign inside the derivative symbol. So ddx of minus cot x is cosec square x. It implies that what? Integration of cosec square x dx is equal to integration of cosec square x with respect to x is minus cot x plus constant of integration c. Here is the formula for integration of cosec square x dx is minus cot x plus. Next, ddx. Sec x is known. Yes, derivative of sec x is what? Sec x into tan x. Sec x into tan x. It implies that integration of sec x into tan x with respect to x is equal to integration of sec x into tan x with respect to x is, yes, it's simply sec x plus c. Here is new formula for integration of sec x into tan x dx is equal to sec x plus c. Okay. Next, ddx of cosec x. We know that derivative of cosec x. Yes, derivative of cosec x is minus cosec x into cot x. Multiplying both sides by minus. Why? We are interested in finding integration of cosec x into cot x. That's why I multiply both sides by minus 1. So minus ddx of cosec x is equal to minus minus becomes plus cosec x into cot x. Now here in LHS minus sign is outside the derivative, take inside the derivative. So d dx of minus cosec x is equal to cosec x into cot x. It implies that integration of which function cosec x into cot x, integration of cosec x into cot x with respect to x is equal to minus cosec x plus c. Okay, it's our new formula for integration of cosec x into cot x dx is equal to minus cosec x plus c. Next, we find another formula of integration by using the formulas of derivative. Yes, we know that derivative. Yes, d dx of x, derivative of x with respect to x is what? 1. It implies that integration of 1 with respect to x is x plus constant of integration. Okay, it's very simple. Remember, integration of 1 with respect to x is equal to x plus c. Next, d dx of kx. Okay, where k is constant, derivative of k into x. K is constant, take outside the derivative symbol, and derivative of x is 1. K into 1 is k. We know that dx of kx is equal to k. This implies integration of any constant number is equal to constant into x plus c. Okay, it's our new formula for integration of any constant number is equal to constant into x plus c. Okay, now we have find some formulas of integration by using inverse trigonometric functions, derivative of inverse trigonometric functions. We know that d dx of, yes, d dx of sine inverse x. Tell me the derivative of sine inverse x is 1 upon square root of 1 minus x square. Also we know that d dx of which function? Cos inverse x, which is equal to minus 1 divided by root of 1 minus x square. Now we are interested in finding the formulas for integration, not for plus sign, minus sign, etc. Okay, constant terms. So multiplying both sides by minus 1. So it becomes minus d dx of cos inverse x is equal to minus minus becomes plus 1 upon root of 1 minus x square. So taking minus sign inside the d dx symbol. So d dx of minus cos inverse x is equal to root of 1 minus x square. Here derivative of sin inverse x is root of 1 minus x square. Derivative of minus cos inverse x is root of minus 1x. Root of derivative of minus cos inverse x is equal to 1 upon root of 1 minus x square. Now we find the formula for integration of 1 upon root of 1 minus x square dx is equal to, either you can write it's sin inverse x plus c, or yes, another formula for integration of 1 upon root of 1 minus x square is minus cos inverse x plus. Okay, here is the new formula for integration of 1 upon root of 1 minus x square with respect to x is either sin inverse x plus c, or it's minus cos inverse x plus c. Again, we know the formula is for derivative of tan inverse x. Yes, derivative of tan inverse x. Derivative of tan inverse x is what? 1 upon 1 plus x square. Okay. Also the similar formula for derivative of which function? Cot inverse x is minus 1 upon 1 plus x square. Multiplying both sides by minus. 1. So minus d dx of cot inverse x is equal to minus minus becomes plus 1 upon 1 plus x square. Taking minus sign inside the derivative symbol. So d dx of minus cot inverse x is 1 upon 1 plus x square, and here d dx of tan inverse x is 1 upon 1 plus x square. From both the formulas of derivative, we say that integration of which function? 1 upon 1 plus x square with respect to x is equal to, it's either tan inverse x plus c, or the integration of 1 upon 1 plus x square dx is minus cot inverse x plus c. Okay, these are the this is the formula for integration of 1 upon 1 plus x square with respect to x. It's tan inverse x plus c or minus cot inverse x plus c. Next, we know the formulas of derivative of sec inverse x, okay, and derivative of cosec inverse x. Here, derivative of sec inverse x is equal to what? 1 upon x root of x square minus 1, and derivative of cosec inverse x is equal to what? Minus 1 upon x root of x square minus 1. So multiply here both the sides by minus 1. So minus d dx of cosec inverse x is equal to minus minus becomes plus 1 upon x root of x square minus 1. Taking minus sign inside the derivative symbol. So d dx of minus cosec inverse x is equal to 1 upon x root of x square minus 1. From these two formulas, we find the formula for integration of 1 upon x root of x square minus 1 with respect to x is equal to what? It is either sec inverse x plus c, or yes, from second it is minus cosec inverse x plus c. Okay, so here are the formulas of integrations from derivatives. I think you understand these formulas very well and revise the formulas. Okay, thank you all of you.